Ready?
Yeah.
Faster. Oh, too far. Pull it apart.
It looks kind of good.
Yeah, honestly.
It didn't look very good. It came out with a very rough surface and a lot of big air pockets, so I cut it up, threw it back in the crucible, and melted it down again. The metal is bronze. It's about 95-5 ratio of copper to tin, so it's a more copper-rich bronze than typical. The wood I'm using is cork oak, which is very, very hard, and I figured that might work well for this project since it should char less than a softer wood, but I am really putting that to the test. For the second attempt, I tried heating up the metal luge to see if that would help the bronze flow better, so we held a torch on it for about 15 minutes prior to pouring. The difficult part here is the two-man system. It's tough to get the pour and pull speed on the same page. It also doesn't help here that the bronze was sticking to the luge even worse now, which I guess heating up the luge made it worse in the end. The luge was supposed to help reduce turbulence in the casting, but obviously it's not quite helping here. This casting didn't fill in all the way, in large part because like 50% of the bronze got stuck to the luge. So now we're on to attempt 3, and the wood is charring pretty good, but that's actually a good thing in terms of getting a quality bronze casting. With each failed pour, the wood is charring more and more, and therefore reducing the moisture content on the live edges of the wood. The moisture content in the wood is a large part of what's causing the porosity and any air pockets in the previous castings. So by burning the wood throughout these attempts, it's actually improving the potential quality of the castings going forward. And on this attempt, I decided to get rid of the metal luge since it was hurting more than it was helping, and just pour the bronze straight into the void. And look, I know there's a million different ways to build a metal river table, methods that are far more sane and easier to pull off. Over the last few years, I've seen videos of builders casting metal into river tables, but they're using aluminum or other low melting point metals that, in my opinion, don't look nearly as good as copper or bronze. Bronze melts at around 800 degrees higher than aluminum, and to my knowledge, no one's been crazy enough to try it until now. This is, without a doubt, a ridiculous way to build this table. A more sensible way to do this would be to create a plug in the shape of the river and cast that in sand, and we've actually done just that on a previous table. It worked pretty well, but I wanted to see if it's possible to do it this way and how different it might look with the charring. And finally, on this third attempt, we got a usable bronze casting of the river void. I cleaned up the charred edges with some steel wool just to remove any loose pieces of char, sealed the charred live edges with resin to stabilize them, cleaned up the bronze a bit with a grinder just to make sure it will lay down flat when I assemble the table, and cleaned up the edges as well so that I can get a good bond for when I glue it in. Lined out some silicone and stuck the slabs on it to create a watertight barrier. Mixed up some resin and poured just enough to fill in any gaps along the edges of the river between the metal and the wood. This will ultimately bond the slabs to the metal river. I poured in some black resin over the top of the river, not much, just enough to give an even surface over the metal. And this was kind of part of the goal, to make a river table with reduced resin use and in place using a different medium. In this case, we're using bronze. Now came the fun part, which is router planing this tabletop until the bronze is completely flat with the slabs. And I had to do this after gluing in the bronze river, otherwise I'd never be able to get the bronze river on a perfectly flat plane with the slabs. Routers aren't really made for cutting metals, but if you've got a carbide bit, and lots of them, it does work okay. It just takes a long time. This process took long enough for me to never want to attempt this method again. After about 30 or 40 hours of router planing, I finally had the tabletop surfaced and flat. Milling the bronze down did open up some small holes throughout the bronze, so I decided to carve out any rot on the slabs and do a thin flood coat of resin over the whole tabletop to fill any holes in the slabs as well as any holes in the bronze. I thought about brazing in some bronze into the holes on the river, but the heat created in brazing would likely heat up the river to the point where it could potentially delaminate from the slabs. Flipped the table over and routed out a rectangular recess where I can fit a timber plug on the back to fill the void under the river. And I could have just filled this entire gap with more resin, but like I mentioned earlier, the goal here is to use as little resin as possible in this build. So instead, I used an oak plug to fill that space. Got that surface plane down to the slabs, and then I squared up the edges on the table, which I had to use a combination of a circular saw, a hand saw, and a cutoff wheel just because of the combination of different materials. Got the rest of the top squared up on the table saw and added a chamfer to every side of the top. This is just more of a design choice than anything else. Then came sanding the top to remove any router marks, and this takes a long time as well. Gotta use a big base on a sander, otherwise you'd end up creating a dip around the metal river since metal is so much harder to sand than wood is. Applied a hard wax oil to the wood to bring out the grain and add some protection. Taped off the edges of the river so that I can polish the bronze without accidentally polishing the wood. Spent the whole day getting the bronze polished to a mirror-like shine. Mounted on a table base that we made out of some oak, and this thing is done. Overall, it took a little over a month to pull off. It was a ton of work, a very labor-intensive project, but it did come out looking pretty cool. It's a console-style table made to go like in a hallway or under a TV or something like that. It basically just worked with the shape of the oak slabs that I used. Like I said earlier, there's many other better methods to achieve this look that are easier to do. Can't say it was totally worth the effort, but in the end, I'm fairly happy with the way it turned out. That's all. Thanks for watching.